Hello students, this is lecture number 9. Okay, and in the last lecture video we did some Scilab programming. Yeah, Scilab is a programming language. This is a package which is similar to MATLAB. Yeah, so we solved problem number 2.3 and which looks like this. So this is a truss problem. So the problem is like this one. Here this is fixed, here this is also fixed. Fixed means pinned basically, and there is a load here which is applied here. Yeah, so load is 10 Newton here, and distance is from here to here is 1 meter. Similarly from here to here is also 1 meter. Yeah, okay. Note that we did the programming, however some correction we still need there. One thing is the length of this member will be √2, because the horizontal distance is 1, vertical distance is 1, so this should be a square root 2. Yeah, so this should be what the distance should be. Length should be √2 from here to here. Okay, so this correction we will make in that program now, and also we have to also find out the stresses. Yeah, so we have found out so far we got the reaction forces U and all. However, once we change this one, the length to √2, then the stiffness of this member is going to change, and because of that there will be some difference in the displacements we got, but it will be still it will be closer. The reaction forces will still be the same. Okay, so we will see that, and after incorporating these corrections we will try to solve other problems. Okay, so that's what we are going to do. Okay, okay, so we are going to start do the correction. So what you see right now is the Scilab on cloud, and we are going to make changes. Okay, so to begin with the changes, the first let's correct the problem number itself. So this is problem number 2.3. so 2.3. okay, okay, now if you see here, what we have is the area which is similar is the same to all of them, means 0.002 meter square, and then K we have written which is equal to EA over L. Yeah, where L we are assuming is the same for all of them, but for one of the element the length is different, which is √2, so that correction we have to make it. So we can write differently, so we can now program such a way that this can be used for any truss problem. Okay, so what we will do is instead of giving writing just L, we can also enter the xy. Okay, xy meaning that we can enter the the coordinates, and from where we can find out the length. Okay. So we can say x, y, which is the coordinates, is equal to then we had all the nodes, and in the original problem the node number 1 is at 0 0, so we can write it like that. So we have 0 0 0 is the node number 1. Okay. Then node number 2 is 1 0, so we will write 1 0 is node number 2. Then we have 1 1 as node number 3, and then we have 0 1 0 0 1 add node number 4. Okay. So okay. So what we have right now is the coordinates, nodal coordinates, we can write it. So this is nodal coordinates. Okay. 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 So once we have x, y, now we can find out the length. Actually, automatically we can find out the length. And how? Since we know we have the connectivity matrix here, right? So we have Ij, which is the we call it connectivity matrix. Yeah. So I am writing here. So given Ij and xy here, we can accordingly we can find out length. Okay. So the length we can write here. Okay. Length we can have so write length is equal to we start a new vector. So we can have length equal to zeros, okay, and zeros, and how many? It should be equal to a number of elements, right? So number of element is we can write it as NE, okay, 1 comma 1a, right? So 1 comma NE, that tells you that the length is a vector whose dimensions is 1 by number of elements. So each number of element, each element will have one length, we will store here in length. Okay. So vector of element length. Okay, done. Okay. So once we have that, we can calculate the length also. And how do you do that? We can write a function also, or so if you have to find out, how will you do? So given the we can have a for loop, yeah. So we can say for we can have j equal to 1 to number of elements, yeah, so number of elements, and we will do what? We are going to find out. So where NE, in our case we are writing NE here, NE equal to, we are saying NE equal to 4, but no need to write like that. We can actually find out number of elements based on the connectivity matrix, okay, and number of nodes we can find out based on the coordinates matrix, right. So every node will have one entry there. So let's write like this one. So we have xy nodal coordinates. So we can define n right here. N means number of nodes, and n equal to, we can say size, okay. Okay, so n equal to size of what? Size is a function, size of x, y, and this one is the, we are going to write one row corresponds to one node, so we will have 4 of them. So we are going to find out the number 1 dimension, okay. Number 1 dimension meaning that row basically. So number of row, n equal to number of rows of xy matrix, that's what it means, okay. So we can write here in n equal to number of rows, number of elements basically, sorry, number of nodes, yeah, number of nodes, okay. This k we will not need probably, okay. So let's not write it here, we will need later, but okay, let it be here, later we can change it. These nodes we never used it, so let's comment it. We are okay. Now ij matrix is given, and this tells us how the elements are connected, and from here we can find out number of elements. So NE will be equal to size and then of ij, okay. So ij, and again number of rows will be the size of the will indicate the number of elements. So this is how we can give, right. Okay, so ij and row number of rows will give us the number of elements, okay. Okay, so we have that, okay. So then number of elements we got. So length is equal to zeros, 1 to n zeros, of size 1 by ne, means each of the element will have a length, and we can calculate length as, you can say length, and then which one? J, jth length. J is equal to equal to, and then we are going to find out ij basically, right. So, we have node number, so we can have nodes equal to okay. So, nodes equal to we can have n ij ij, and we are going to for jth element we have to find out which are the nodes. Yeah. So, so how will we find out? We say j comma and we will have right column. So, it will take the jth row basically. Yeah. Okay. So, this we got nodes. Okay. So, the we got two node, we will get two nodes basically, and node let's write okay nodes. Okay. So, so nodes 1, the xy of node 1, right. So, we can get x1 is equal to x1 equal to xy of what? Nodes 1 and nodes 2, right. So, x1 equal to xy of nodes which one? 1. So, remember we have xy defined, which is defining here, and we have row number 1 has the xy coordinate of node 1, and similarly this is node 2, this is node 3, this is node 4. So, for node 1, for every element it will have two nodes at the either end, two nodes, total two nodes. So, for these two nodes we want to find out the coordinates. So, if the node number is 2 and 3, so we will find out these first and these first. Yeah. Okay. So, similarly, so that is what we are doing here. So, we got two nodes. Now, we can write like xy1. Okay. So, probably this may be good idea. So, xy1 equal to xy and nodes 1. Okay. And then we will have column like this. Okay, this is x1, xy1, xy2 is equal to xy nodes 2. Okay. So, okay, so we get xy coordinates of the two ends, and so we can find out the lengths. Okay, so let's say dxy is the difference, so we can say xy 1 minus xy 2 . Okay. So, this gives us the x difference and y difference, and we can find difference of x square plus difference of y square is what the length is, right. So, we can find out L square, right. So, we can L2 means actually L square L2 will be equal to dxy. So, dxy we will have x and then y xy. So, the dimension will be 1 by 2. Yeah, so 1 by 2. So, dx multiplied by, we will multiplied by dxy prime, or transpose basically. So, 2 by 1. So, 1 by 2 multiplied by 2 by 1, and that will give us L square. Yeah. Okay, so we can write like this one, and hence length j will be equal to nothing but a square root of L2. Okay, so this is how we get all the length, and we say end here. Okay. Okay. So, this way we can find out the length of every elements automatically is calculated. Okay. And once we have that, we can actually find out the equation, the stiffness matrix. Okay. So, L is 1, we have E is given this x, y, n, k. We will not write like this anymore because the length is not fixed. So, not write like this one. I j we have any length we are finding out, and then we have k e. K e we will just multiply. Okay, remember the area can also be different, length can also be different. So, accordingly you can change it, but here we will assume that area and the Young's modulus both will not change, hence we are not doing anything, but length is changing. L equal to 1 is just for reference basically, so that when we say when we say L equal to 1, so we can have this one probably, yeah, yeah. So that this is for unity length. So whatever length we get, we just multiply, you know. So so let it be there. Okay. So we'll write rather here unity length. Okay, purposefully L equal to 1. So we have k E A over L, and hence we have k is like this one, and we know that L will appear length will be EA over L, right. So we have to divide by L and we will get it, right. So yeah, so we can write it like KR equal to like this one divided by and then we will have length, which length, we can have equal divided by length. So that means we will along with angle KE we should also get the length as well. Yeah. Okay, so element of the length we will get as input and then it is going to divide by length and it will go. Okay, we got it. Okay, so now angle we should also calculate the angle. Yeah, so in the length we are writing, we can also write here angle, and there should be another vector which will have angle. So we will say zeros here too, and we'll have 1 comma NE. Okay, so this is for angle, and we can also the way we are calculating the length we can also calculate the angle as well. So we will say angle J okay angle J equal to okay, and how do we find out? We find out by total length. The our angle is from the x like we are measuring from the x, right. So if the difference in y divided by difference of x, that we are going to find out, right. So we can have angle and then we have a tan, right, a tan, and then we will have a tan 2 probably. Yeah, so a tan 2 actually this finds out based on 2 input. So a tan 2 is it should have 2 inputs, one will be del x, other will be del y. So okay, so let's see. So we have a d x okay, so we have dx1. So maybe the x comes first, we will check it later. So let me write like this one dx1 and sorry it should be dxy1. Okay, so this is difference in x and dxy 2. So this should be difference in 2. Yeah, like this. Okay, so this should give us the angle. Okay, so we will just comment here check. Okay, so just to say check here whether is correct or not. So we will check later. So we got the angle. Okay, and here we are giving angle and length as well. Okay, so k 1 to any kr equal to angle ke and then and also it should be the length. Okay, so angle I, so right angle and length I, length I. So here length I, care को rotate. Okay, so automatically we got all the values here. Okay, so length we will get, and so let's execute and find out whether it's working. Okay, there may be some errors, so we have to check. Okay, so it says attain 2 is not there, so we can actually check it. Okay, whether this kind of function is there or not. Okay, the function is a tan only, so we don't have to write it a tan 2. So a tan 2 is in MATLAB. So here it is just a tan will work, a t a n. So we have that, and y comes first and then x. So accordingly we are writing that. So 2 and 1. So we have checked it, so it should work now. Okay, so execute. Okay, so we got some results. So undefined variable, current prompt at line 70 input call by enter the value input. Have no idea what it is talking about, but we have got the u free now. What we see right now is let's see, the we have 1 2 3 4, f will be 4, u free, so 1 2 3 4, f is total 8, so 1 2 3 4 5 6 7 8, and then we have error. So error maybe because of something, but what we are getting here is we have calculated all, we have rotated the elements, we did all the automatic rotation. Basically we calculated the angle, so we did everything. So what you have to give here is the nodal coordinates you can give. You give the connectivity matrix, and it can calculate everything by itself. You can calculate length of every element, then you can calculate the it can calculate the length and angle both, and then this angle basically is not needed, so we are going to comment it now. Yeah, so and length, and how we are calculating, we are calculating the length in as we have done here, length and angle both, and those things are being used and finally we are going to find out so okay. Okay, so although we have some error here, but we got all the answers, so this may be just a warning. So we can also check it. We can copy it all and put it in the older one to see if uh, it works. So let us execute again. Yeah. So there is no error now, so it's good. So we have the answer now. So as you see, we have in the force we have all uh, almost 0 except there are 4 of them which is non-zero, so we have 10 of them like this one. Yeah, okay. So we have solved it, we have corrected automatically, it can do. Yeah, now we can add the stress as well. So how to do? We have the u, we have the f vectors including the reaction forces here, 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 and we know the displacement. We know where how much these are moved. We know how much these are moved up and down, whatever. So value will be 0 here. So if we know the displacement of this up and down like this one, then we can find out what is the strain in these elements, and accordingly we can find out the stress. Yeah. So let us say there are two nodes, any, okay, and we have this system, right? So like this one. So we have u1, u2, u3, and u4, right? And this now we want to convert into this big U1 and big U2 system, right? Yeah, means along the axis, right? So or along the member itself. So how to do? So if we know the angle, right? So we have the theta here, we have the theta here, and then we can relate, and we know that u1 is equal to nothing but u1 cos theta plus u2 sin theta, right? And similarly u 2 is equal to u3 cos theta plus u4 sin theta. That's what you get. Okay, so that means we can have like this. Probably we have done this earlier also, probably, but repeating it. So here we will have one matrix, and we are going to multiply it with u1, u2, u3, and u4. Yeah, okay, and then we have cos theta, sin theta, 0, 0, and then we have 0, 0, cos theta and sin theta. Yeah, so we have this transformation matrix T, let's call it, and this is going to transform the 4 displacement system to 2 displacement system, and once we have this one, we can, this will gives us how much this has moved, how much this is moved, and difference of the two will give us the strain, right? So strain will be equal to u2 minus u1 over L, yeah, or simply this will give us 1 over L minus 1 1 and u1 u2, right. Okay, this is what the strain will be, and we multiplied by Young's modulus E, so we will get stress, so sigma equal to E times. So this is what, how you have to do it, and same thing we are going to do. So we will write in the program the same thing to find out the stress and strain. Okay. Okay. So let's find the stress. So we have U, which is 8 8 by 8 system. 8 by 8 system means the total 8 degree of total 8 degrees of freedom. So for every element we can find out the stress now. Yeah, so we can say for loop for I equal to 1 to number of elements. So for every element we can find out. Okay, and what we are going to find out? We will find out first we have to find out the nodes, right. So which all nodes are there. Okay, so for every element we have nodes 1 and 2. For example, this one, let's see, we get from Ij, so exactly this we want. Okay, so node 1 will be Ij1, node 2, okay, okay. So we get 2 nodes. Okay, these 2 nodes, based on these 2 nodes we are going to find out the U's. Yeah, so U1, so write U1, okay, U1 equal to we have, or okay, so simply we write U4 system, right, U4 or a small u, but element, right. So UE, so UE will be equal to UE will be equal to, we have big U, yeah, and big U, but we will have node 1 first. So node 1, 2 multiplied by node 1 minus 1. Okay, so this, or we can give that later. So then we have can also do it comma, and then we can write U similarly 2 times 2 times node 1 comma u, we are going to repeat it for node 2. So 2 times node 2 so like this, and not a good editor, so because of that we are facing problem, uh, but you are getting the idea. Or anyway, since it is slow, so you can also do your coding side by side, so you can watch video and do your own coding as well. So 2 nodes to node 2. So we have that, and we also transpose it like this. Okay, so we got that. So we are capturing all the u values for that element, and node 1 and node 2 we know for every element we get. So u e we get already, and then what we have to do, cos theta. So we have a t transformation matrix or rotation matrix basically. So and we have cos. So let me, if we can copy from here also, I think the equation is exactly something like this one only. So you can copy from here. Okay, so cos theta sin theta. So this is ang we are writing, ang we can what is means is angle, we can write angle, and then angle I for ith. Similarly this angle I okay, and then we can have 0 comma 0 comma again these values, so we have cos and sine. T cos sine 0 0 0 0 cos and sine. Okay. So, this is what we had got. Okay. So, now u e we have, now we want the big U. So, we will write it u e, let us write it. This is the along the axis now. Yeah. So, is equal to, we will have T times u e. So, this is transforming from 2 displacement from 4 displacement system to 2 displacement system, right, the way I explained. Yeah. Okay. So, we have u e now. Once you have u e, we can find out the strain. Yeah. And strain is, so we can have a strain, we can define the strain, find the stress and strain, stress and strain. So, enter, let us call it a strain equal to zeros, and for every element we have, so 1 by Ne, so Ne by 1 probably, N E comma 1, okay, and we can have stress 2, we can have like that, but this is stress. Okay. So, we can have now a strain, ith strain. So, a strain ith, okay, is equal to, and we know that what we do, 1 over length, okay, length we can have later. So, we have -1 and then 1, okay, and after that we have multiplied by u e, then divided by, so this gives you u2 minus u1 divided by length. Okay. So, the length, we know that for every element has one length, and we are storing in this, so we have a strain here, and similarly stress will be nothing but stress I multiply stress equal to big E multiplied by strain, okay, it's a strain, ith strain. So we have a stress and a strain ready. So say enter, and we have to close the loop, for loop. So we call it end now. So close the loop, and we can have a stress to output. Okay, so this gives us a stress for all of them. Okay, okay. See, a stress or disp means display the stress. We can write like this also. Okay, like this. Okay, so let's execute and see whether it works. Because of internet connection, it was taking long. So if we try it, okay, so we are getting now. So you can see that. So we have got this value. So u free that we calculated in the last video, and we are getting the stress as well. So what you see, the stress 0 means 0 is for the first element. Okay, so there is no stress in first element. Then in the second element there is a compression. Okay, and in third one, in the third one it is saying there is a compression again. In the fourth one it says this is a tension. Yeah. Okay, so element numbering you have to remember actually. Okay, so here sign probably may have some problem. So I think the way we numbered it, so one is vertical, so its second is horizontal, so it should have tension rather than compression. Then we have fourth one diagonal. So just looking at it, look, it should be in compression. Fourth one should be, fourth is diagonal one should be compression. So it looks like we are getting the sign, somehow we are not getting the actual sign. So what is the problem then? So let me see. So u1 u2 minus u1. Okay, so we have to see angle and all, whether it's correct or not. So let's see how we calculated the angle. So okay, so angle first x y1, so first node x. Okay, so angle I think you have to revise. So instead of saying dx1 minus dx2, we will say dx2 minus x21 xy2 minus xy1. Okay, so now we should, I mean now the angles accordingly calculated, we should get the opposite values. So let's execute. So this way you have to debug basically. Yeah, so we are getting values, first will be 0, second is positive value tension. In the third element we will have tension, and the fourth one diagonal one should be in compression. So values are correct. So this is how we calculate. So what we did, we have corrected the like the length for the one element, but now the way it is written, it can be any problem can be solved using this one. So it is not just the problem number 2.3, any Truss problem you can solve. What you have to do is, in the this nodal coordinates you have to change depending on what the problem, what is nodal coordinates in that problem, and then you have to change the connectivity matrix to define the whole truss, and based on that automatically it will calculate all the length of the member, orientation of the member, it will calculate everything automatically. It will also calculate the stress for all the elements. So you can actually, you may try solving other problems using this program. So, I will post this program in Google Classroom. Okay. Yeah, so that is all for today.